So today we can start with the functions, but before that, I want you to just, we can probably do a bit of, yeah, so next would be your functions, but before that, let's try a bit of coding. Let's try using a little bit of loops and, those things.
Okay.
So we have seen, right, this thing for last day we were just looking into it. And if we want to print something like that, it's gonna give me the print of, numbers and something like that.
Yes.
So can we leverage this and come up with, let's say, some sort of addition, or let's say some sort of, counting the list? Can we do that? Let's say there is a list. I don't know. Have we used that already, or maybe not? We have not used that. So let's say there is a list. Okay, there are some random numbers. Now I need to know what is the sum of this list. So len function will tell me how many items are there. 1, 2, 3, 4, 5, 6. But I need to know the sum of it. So for that, what I should do? So the first thing is I have to just think logically. uh, Loop is iterating one at a time. So loop is something which cannot access all the elements at one time, right? So
Okay.
loop can only access one position at a time. So when I is equal to 0, it can access the 0th element. When I is equal to 1, it can access this first element, and so on and so forth. So what if we create something, some mechanism which will take one value at a time, keep it somewhere, and then it will move to the next one and then add it with the previous one. And if we can continue this mechanism, so by the time we'll reach at the end, we will sum this with the sum of all that, which will give me the sum of the entire list. So that is something that we can do. So the first thing that we have to do is we have to create an empty list. So this is how we create an empty list, right? So
Mhm.
L2 is a list, but it has no data element in it. So we will call it as an empty list. So what we have to do is, so this iteration, let's see. So, okay. So for any writing or coding anything, so the first option would be try out the same operation with a print. If you are getting the same thing with print, that means then you can do your summation, deletion, and all of that. Yeah, so yes, I can access the elements. So print of L1 of I. So this I is changing from 0 to this. So I can access that. Now, let's say if I want to store it into somewhere. So I showed you, right? There is an append and there is an extend operation. So what we have to do, we have to do L2 dot append. That's it. Append of that particular element, 0th element. And now if I do a print of L2, let's see what it shows. It's working. This is working, right? So let's see the value of I. So this is the value of I, and we can just play around little bit in the print statement. Ith position. See, now I am able to create, sorry, dot append. Okay. So it's basically taking the older one and it's creating it, putting it into the new one. So the point is I am able to access each and every one. But now my objective is to add it up. So I have created a new variable, which is sum. Sum is equal to 0. And what I can do is append of sum is equal to sum plus this element sum. See, now it is working. Or if I do it like this, print of sum, it will tell you the sum. It will okay, let's do I position, comma, the quotation ends, comma, and then the sum. So see, now I think the picture is pretty clear. So what it's doing, so the loop is traveling through each and every data element, and what it's doing is eventually, so we can keep this simple as well. There is no need eventually to create this new list. You can get rid of it. To take a sum, this would not be needed. So yeah, so this is the sum. So first I have initialized a new variable with 0 in it, and after that what I am trying to do is every time I am adding the latest value and I am adding it to the sum. So for the very first instance, 0, sum is equal to 0, and i's value is also 0, but L1 of I is 5. So for the very first instance, sum is equal to sum plus 5, which will become sum is equal to 5. So that's what I'm getting here. The first instance, the position is 0 and the sum is 5 because it's just adding the first element. While moving to the next one, what it's doing is just adding, taking the previous one and adding to the current one. 5 plus 6, which is 11, and so on and so forth. So this technique we would be using in moving average. So there is a concept called moving average in mathematics, which comes as part of time series analysis and those things. So that goes like that. So you take the present value, add it to the previous. So that's how we would be able to tell the sum of it. Now, the reason why I have taken out L2 is L2 was creating a duplicate list out of it, which is not really the need of the R. So right now the need is to do a sum of it, right? Any questions?
No, no.
Okay. So that is how we can leverage loops to calculate the sum of a list. And there are multiple other options as well. So, so there are multiple ways of, I would say, doing these loops and all of that. So that is one thing. Input, have you been able to try that on your end?
Yeah.
And was it working?
No, I just was listening. I didn't try it.
So until unless you try, you wouldn't be able to get, that desired thing if it is working or not. Okay. So can we use the same logic to calculate any number until, let's say, how do I put it? Let's say user will ask me to calculate all the numbers until 10 or until, like 50 or 100 or until X. So can we use the same logic to calculate that? The answer is yes, we can do that. So so the answer is yes, we can do that. So all we need is, let's say there is, yeah, okay. So as part of the whole number, so we know in mathematics, it's like all the positive numbers until a certain point. So let's say the customer has asked, to calculate all the whole numbers until a certain point, let's say 5. So what we have to do in that case, first we have to create a blank list, L2, and whatever the numbers we have, like the user will give only 5, right? So what we have to do it like, we have to take all those individual, you know, uh, we have to rotate through it, like if we put range and if we put 5 we make 0, so we can iterate through all the value. We can start from 0 and go till 5, and at each and every position we can just add a sum to it. So first we have to initialize sum to 0 and just add a sum to it. So that's how we can calculate, we can calculate all the numbers until a certain point. So that's one thing. And okay, so loop has very interesting this thing in terms of layouts. Print of star. So this we know. So I want this star to be printed 6 times. So it's just giving me 6 printouts. But the fun part is, let's multiply it with this thing, with that particular value. Okay, so if we do this, what it will do? So comma, just remember during print statement, so comma will basically separate two things, and you can input n number of arguments in it. So that's what comma does, right? Now, instead of comma, I just want this to multiply it. Let's see how it works. It's taking the shape of a pyramid. So what eventually it's doing? So I is the index, I is the counter, I starts from 0 to 5. And this one, this asterisk is basically, this is a multiplication operation which is happening inside the print statement. So whatever value we have, if we put a multiplication operation with any of the character string, it's eventually multiplying those many times, and that is the number of times it's just, giving a print here. So when the value is 0, it's nothing. If it is 1, then I'm getting 1. If it is 2, then 2, 3, 4, 5 accordingly. So see, I'm not getting 6 here because the 0th one is not coming. That is the fun. But if I do this, see, I'm getting 6 entries. 0, 1, 2, 3, 4, 5. But if I just multiply it, I'm only getting 5 entries. So that's how you can play around with this. If I put this, like we can create probably a table, a mathematical calculation tables So those are few of the things we can play around with, or we can create multiple shapes here. Print of what if we just put a blank here and we put a blank here as well. So yeah, so these are few of the things that we can use to come up with different shapes. So these are more or less, interview questions. In a real world, you would be hardly using these kind of things. So these are majorly important in case of a, in case of an interview questions and those kind of scenarios. So that's in short about this. Now let's do one thing. Let's jump into functions, because that is probably one of the important thing in Python. I'm just closing this, opening a new tab here. So these I had already created yesterday, and the things that we would cover here. So functions, intro and syntax, user defined, built-in function, function parameters, types of arguments, lambda function, global and local variables. So that is a global variable, and these are local variables like that. So what are functions? So functions are something which are kind of predefined, thing like, this is the best example of a function. This is the best example of a function. Print statement. Now, why print statement is a function? Because I am just calling I'm just calling this function to get an output. I'm just calling to pass a particular value so that this will appear on the output window, on the, on the outside window. I am not bothered about how it is doing that. I'm not bothered about how the inputs are getting converted into outputs, right? So I am not at all bothered about who is doing that or what is the code, who has written all of that.
Hmm.
So is star a single star. I'm not getting this point. I'll show you later. So yeah, so the point is, so this is one of the good examples of function. So long story short, function is something which will or will not take anything as an input, but it will give you something as output without we bothering about how it is doing. So that is all about function. So until now, we have seen couple of functions like length, we have seen append, we have seen extend, then for any operation like, let's say x is equal to 5. So this is a variable. So if we do the usual technique x dot tab, what are the things we can do? So as integer ratio, this is a function. These are not functions. So best would be to create a list, a quick small list. Yeah, let's start with these three. So this is a list. So L1 dot tab. So this will show you the number of functions we have here as part of Python. And we don't have to define it. We don't have to do anything with it. We just have to call it. So these are the different functions that we have. So you can just pop, remove, reverse, sort. It's pretty self-explanatory. It will tell you, what exactly this function is doing. Now, function usually has two things. Once the first thing is function body. So I'm not going very details into it, but just, it's just, these are good to know facts. So function has something which is body, where the main code would be written, where you will have your main code, where actually the code will be written here. So it will be stored as part of the Python package where, these things are actually installed. So if you go to C drive and all of that, so there you will actually find the Python, the function details, or what are the codes written to actually be able to create this particular function. But that's something that we shouldn't really bother about, because those things are crucial for, people who would consume Python as IT, as like, as part of their development work. But we would be consuming Python as part of data science, as part of a data scientist, to analyze data, to derive something out of it. So that's why we would not be needing those much of information. We don't need to go there literally. But yeah, so function has, there is a body which has the main written codes in Python, which has lot of, something written, hash include, what to do, what not to do, all the logic, pseudocodes, everything is written there. And once that function is written somewhere, we call it defining the function. So that function must have been defined somewhere. But while using in our day in day out operation, what we will do, we will just call the function by the function name, by the name of it. Now, a particular function might have a, might have a this thing, might take argument as part of it, might not take argument. That's a second discussion. But that's how we will be using a function. So for our case, this is the part that we would be bothered about. So we will just, consuming it. So we will just call the function. That's it. We will just call it by its name. Now, how can we create a function then? So that's okay. Now that's what a function is. Now, as part of our data science process, we might need to create some functions on our own, right? So first thing is what exactly this is doing. So take the example of print. So print has been written in such a way that whatever you write or whatever you send as part of the argument, it will just give you that same output without changing any materialistic value inside of it. But yeah, we can probably play around with the font, with the, those things, font layout and those things, but it will retain the same thing. That's what the print function is all about. The length function is meant to count the number of elements present inside a list, or a tuple or something like that, or a string. So that's what length is meant to do. You following it, Ranjit?
Yeah, but I'm getting syntax invalid syntax error.
Where exactly?
In L1457 I have mentioned. So I
Hmm.
have the define function body, but I'm getting the invalid syntax.
No, no, no. The define function, see, the define function body, this is just, I have written to let you understand this thing. See, this is a markdown. This is not a code.
Acha,
If
okay.
I make it code, if I run, I will also get that error.
Acha, okay, okay. The same only, yeah.
Yeah, I will also get that. This is markdown. This is just, just to help you understand how this thing is.
Okay,
But yeah, that's what functions are. So function has a body, and at the end we just call them. That's it. That's what functions are all about.
okay,
So there is a body, it's written somewhere else, and we just call them by the name of it. Now, functions are usually two types. There are some user defined function, there are some built-in functions. Now, these all are built-in function. This length and all of that. Length of L1
mm-mm.
is 3, right? Let's say there is a string of Ranjit. Now, len of str is 7. So, this len function is a built-in function. That means as part of Python, whenever we are installing Python, these are coming as part of it. So we have nothing to do with the function body. So this part, we have no role to play here. We are not doing anything. All we are doing is just calling the function. We are just calling it.
Okay,
That is the thing for built-in functions. But that is one thing where we just need to specify what exactly you need. I need the length of this string. So it just takes a count and it will give you the value in numeric. So what is the data type? So type of length, it's coming in integer. Brilliant. So I can probably take this and run a loop and extract one value at a time and probably put that as part of, a loop for I in range of length of string. If I do like that, and then if I do a print of string of I, if I do, so what this will do, this will extract one value at a time. So that is what the function is doing. Like range is also a function, right? Range is also a function. Range has length inside of it, length has string inside of it. So it's like function within a function. So that is what functions are. Functions are a predefined set of instructions written somewhere and giving the user that flexibility to enter any argument. Okay, understand what an argument is. So whatever we pass in a function or whatever value we use to call that function, those are known as argument, right? So those are known as arguments. We call them argument. So argument are, so for length function, str is the argument. For range function, this whole length is the argument. For print function, this string I is the argument. So these are the arguments we are passing and it's doing that particular task out of it. So that is what function's role is. Long story short, that's what function's role is. To take the user input and do the processing. Now these all are built-in functions. They are built somewhere. We are just calling them by their arguments. We don't need to know what is written there, how long the code is. We are not bothered. We don't need to do all of that. But there could be scenarios where we might have to write some codes on our own. We might have to create some functions on our own. Because not everything is written, not everything is defined, right? Maybe as part of the process, there is a new logic that I need to implement. And function would be the best thing because function is like doing the same thing over and over again. So we can write n number of prints here, right? It's not like you can call it only once. We can put hundreds of prints here. So that is the thing. Now let's see how we can create a function. It's just one simple line, def and function name. Like let's say addition. So def addition is a function that I want to create. You have to put angular braces after that. So that's what I will tell the Python that, okay, this is the name of the function that the user want to create. Put a colon. Now after colon, here write whatever you want to write. Okay. So what I am doing here is, let's say I will take two inputs from user. Let's say A is equal to input of enter a number, and let's say we will enter another number, enter another number. So this will take two inputs from user, right? A and B. But also one more thing we need to do, because input functions, if we use input function, we are going to get the value of A in the form of a string. So we have to change it. We have to make them as integer. So this is what we are going to do. Int of this, int of this. Now we have these two numbers A and B. So what are we doing? Okay, first let's just take these two numbers, return A plus B. So let's write it separately. Okay, A, B. Now C is equal to addition of A comma B. Print the addition is comma C. This is how it will be. Now, I will not be running the input function from my end because it will throw me an error. The input function has some issue with my end. So, but can you try doing it on your end, Ranjit? And
Yeah,
can
I'm
you tell
doing.
me what exactly this is happening?
Yeah, I'm running.
So the good thing is, if you run this def addition once, that's it. It will create an addition function and it will be stored somewhere in Python. So we don't need to run this statement again. Every time what we can do is we can call the addition function with whatever values needed we need to pass. That's it. And it will do the additional operation.
Enter a number like that.
Hmm?
Enter a number.
Yeah, put a number. It will ask it twice. Just put any number, hit enter, and then see again it will say enter another number.
Yeah.
Yeah, because there are two inputs. Just give another number and see it will tell you the sum of it.
Name addition is not defined.
Which one?
I'm getting some error.
No, so have you executed this line? Def addition.
Yeah, yeah, executed. I even like a number is like 12 and 10. So it must be like 22. But
Have you are you sure that these names are proper?
it should be,
It should work exactly. It should not be any error. Just see the at the function name is clear or not.
that is correct. You change the this thing, no?
Yeah, the reason I changed is my input function will not work from on my laptop.
Okay.
That is why I just manually hard coded the numbers. But for you, this is optional. You can take any numbers from the user.
So I'm getting that enter the number, but it is not calculating.
No, okay. So you see the indentations are all of that are clear,
Yeah, yeah,
right?
everything is clear.
So you are entering two numbers,
Yeah, I'm entering the two numbers.
and after that,
After that, it is coming like the name addition is not defined. So a name error, enter all lost cell in 22 line 3, enter input name.
okay, just do one thing. Just run the def addition again. Run the function again, and then run this one.
Again, this one,
Yeah, first run the addition function, def addition, where you're defining the function,
okay.
and then run the other part.
Acha, okay. Can I share my screen?
Yeah, yeah, please. 1 second. Yeah, I'm stopping. Yeah, please share your screen. Hmm. A is equal to input, C is equal to okay, just do one thing. No, you have not executed the first part, right? You have not defined the function. See what it is trying to do. Understand what the error is. It is saying addition is not defined. It
Okay.
is saying the addition function you have not defined. So what you have to do, you have to first define the function. You have to tell Python that, see, this is what addition is supposed to do. Addition is supposed to take two values, A and B, and is supposed to sum them, and it's supposed to give me return that particular whatever the output is. And what I am doing as part of line 3, I am catching that return. So just go sequentially. A is equal to input a number and then integer. So that number is getting converted into integer, right? B is doing the same thing. First input and then integer is converting that into integer, right? Then C is equal to addition of AB. So I'm calling the addition function with these two, whatever two entered numbers are going as part of the addition function. Then it's going into the prior cell, def addition. As part of AB, those two arguments are going inside the function, and then there is a return happening. So what is the return statement? The return says you just add it up, just add A and B, because this is an addition we want to do. So just run this part, and now run the next one. Now it will work. Just put two numbers. Now it is working.
Okay.
Because you had not you have not defined the function. So just just come back to where we were. So we in line 3 we called addition. 10 and 12 were entered as part of A and B. Now we are in the cell 25, the prior one. So here what it's doing, it's basically returning an operation, mathematical operation. What is that mathematical operation? Add do A plus B. So 10 plus 12 is 22. So that 22, we want to return it. Okay, agreed. Now come back here to line 3. So C is equal to addition of this. So C is equal to return of 22. That means that 22 value will be stored in C. So C is equal to 22. And then the next print is just printing the value of C, which is 22.
Okay.
Right?
Yeah.
So that is how you can define a function. So yeah, you can stop closing. Right. So that is how we define a function. We call a function. So the first thing is we have to define it. So this line is important. Just imagine if the print was not defined, then it would have gave us some error, right? Like let's say PRNT. So there is nothing called PRNT. So if I run this now, I will get an error. It will say the PRNT function is not defined. Because that is true. There is nothing called PRNT. But if we define something on our own, then that PRNT will work. Let's say if we create something on our own, then let's say if we, okay, let's do like this. Addition, okay, let's do here. So we know the print function is something that is, that is already defined. That is a built-in function. But there is nothing called PRNT. Let's create something called PRNT. PRNT, what I want to do, let's say it will take the value of A and return A dot lower. So what I'm trying to do is I'm trying to create a function which will basically put that particular, whatever the value will come as part of A, convert that into a lowercase. Convert that particular value into a lowercase. So that is what I am planning to do. Let's see if it is working or not. So now if I run this print of, okay, sorry, not print, this will be print. I want to print it out. Yeah. Now if I run this, now it's working. So let's say all the names here were like this. If I call this, I'm getting, so it's what this print function is doing. So there is nothing called print. So there is something called print as part of the process, which is a already built-in function. So this is what it's doing. So first, the print, which is the already existing function, it's printing the normal value, whatever is there in capitals. But then it's calling my function, the user-defined one. where I am purposely planning to convert that particular cell into a lowercase. So
Oh,
that's why the next input is in lowercase. Loop executed next is going to A. A is coming first. It's a normal print. Whatever the value is, just print that value. And next, what I'm doing, I'm just calling this function, my defined, user defined function. And here again, I'm just doing the same thing. I'm just trying to convert that into lowercase. So the next A is lowercase. And that's how it is. So that's what functions are. That's what functions work. So you're getting a hang of it, right? Like how
yes.
function works.
Yeah, yeah.
So the first thing is we have to define it. Now this is just a one line simple function, but in real world, you might write a function which will have 50 or 100 lines of codes, right? In a real world, in a production environment, in some real world applications, because whatever functions, whatever, already existing functions are there, they serve a general purpose, like printing, summing, addition, deletion, those kind of things. But what if you want something specific to your problem? Like you need, let's say, what else we can do? Mhm. Okay, let's try another function. This will be interesting. Let's say there is a list which has names of uh, yeah, these are like first name and surname, second name. Uh, these are like it, this is a list which has, a combination of first name and second name. Now, what I need to do is I need to create a function which will take this one value as an argument, and instead it will give you the first name and the last name as the output. Right? You following me?
Mm.
You have a list. Let's say this is a phone dictionary. A
Yeah.
phone dictionary list, or it could be a tuple or something like that. It has, let's say, names of people, their first name and last name.
Okay.
Now, uh, let's say there is a need or there is some feature on some application you're working, and you have to create or add some feature which will basically split their names, first name and last name. So what will you do? What will you approach? So the first thing that you do is you create a function which essentially separates one string into two based on a space, because this will be your delimiter. This will be your, we call them delimiter or separator, both the same. So delimiter is something which basically separates a particular string into multiple strings based on a common delimiter. Now here the common delimiter is a space. So this could have been a comma also. So if suppose this was like a comma, now if this was like a comma, then we have to change it. Okay, let's not complicate it. Let's keep it simple. Just put, space in, and this will act as the delimiter. So based on this delimiter, I want my function to essentially divide them into first name and last name. So can I do it? Yes, certainly I can do it. So the first thing that I need to do is L10 dot split. So see the functions change. So just understand this is how important, intelligent this is. So L1 is the list. If I put a dot and tab, it will show you all the operations you can do on a list. And it is very limited. But let's say I want to access the first value. How will we do it? We just put the index number, and that's how we do it, right? So if I put the index number and run, I'm getting the first one. But now if I do the same thing, dot and tab, See, we can do almost everything that we can do with a text. We can capitalize it, we can count, encode, find, format. So these are all is upper, is lower. So these are all different types of functions that we can do as part of text. Now, imagine there is a number here, 5. Now, will it give me the same one? Certainly not. If I want to see what are the operations that I can do as part of the second element, which is 5, these are different compared to what I was getting for Sam Johnson. Because Python knows Sam Johnson is a string, so it was showing me all the string related functions. Now Python knows that 5 is a integer, so it's showing me all the integer related functions that you can do. But yeah, that's just one thing I wanted to show you. But yeah, coming back, all we need to do is we need to somehow split that. So if I split that, what I am getting essentially, so what is the output? So the best would be you can put a type and you can see what are the data type you're getting. So you are getting a list. So if I put L10.split, so it's essentially splitting this one. I am getting a list, which is fine. Now, all I need to do is I need to store them into 2 elements. So I can do it like this. A comma B is equal to split, because I know this split function will split this particular string into only 2 characters. That is why I have mentioned here 2. A comma B, right? Because I know I am going to get only 2 names. So let's say it had a 3 names. Sam, Vic, Johnson. In that case, I would have used ABC for first name, middle name, and last name. But for now, just keep it simple. And this is what I'm going to get. Now, is it like really A and B are getting these numbers? Let's see. A comma B, print. Yes. So print of A is giving me the first name. Print of B is giving me the second name. So now that I understood, I have to use a split function to break them into first name and last name. So that part is done. And how can I store it and all of that is done. Now we have to create that function, which will take this whole list or this particular position as input, and it will just split them into first name and last name. So def names, and here I am going to get one single entity as input. So I'm going to my argument will be 1. So I'm going to get only one value here. So let's say that value is A, or let's keep name. And once this is done, what I'm going to do, this thing. This is what we have to do. So AB is equal to name dot split. So whatever value is coming, it will split and it will put them into A and B. And after that, just put a print here. And then just write it. First name is comma A and last name is B. That's it. So this is my function. This is something which I have defined. Just put it up here. Run it. Done. Now, let's say there is a list. Let's increase the list with one more element. This is another entry. So now what we have, this is a list. So what we have to do is, essentially we have to pass only one value at a time, or we can pass individually as well to do the split. Like we can do like names of L1 of 0. So if we do this, I'm going to get the first name as Sam, second name is Johnson. Manually, if I want to change it, first name is John, second name is Wixon, like that. Or if I don't want to keep it manual, let's say this list is pretty large and I don't have access to the list. I don't know how many characters are there. So in that case, I will use loop for I in range of length of L1. And then what will I do? I'll do the same thing. I'll just call the function. What will I pass through the function? I will just pass one value at a time, L1 of I. So if I do this now, this is the output I'm getting. So first name this, second name this, first name this, second name this. So for the entire list.
Okay.
Understood?
Yeah.
Any queries?
No.
So this split function is something that we have used for, as part of the text. For numerical, for floating, let's say you can do the same for numbers. Like you have a list of, let's say, all whole numbers from 1 to 1 lakh, and you have to calculate all the prime numbers. You have to calculate all the prime numbers out of it. You know, right, what a prime number is? So prime number is something which is only divisible by that number itself and 1. Those are known as prime numbers. So example of prime numbers are 1, 3, 7, 11, 13, etc. So imagine we have a list of all the numbers, of all the whole numbers. And okay, can you do that as part of an assessment? Like you can do it tomorrow also and you can show, otherwise I'll certainly show you. So a small assignment. What you have to do, so take a list of whole numbers. Okay. So this is what you have to do. Take a list of whole numbers. Now, condition is user will provide the number of items of that list. You understood that reference, right? Ranjit,
Yeah.
you understood that, right? User will provide the number of items.
Yes. Whole number items only. No.
Only whole numbers. A list will have, let's say this is this is a list. It will start from, let's say, 1, 2, 3, 4, 5, 6, something like that. Now, user will tell you how many
How many
elements you
whole
need.
numbers is there?
Correct. So user, if we'll say 7, so you will have 1, 2, 3, 4, 5, 6, 7, like that.
Okay.
So user, if we'll say 70, then it will go 1, 2, 7, 8, 9, 10, 11, 12 until 70. So that number will be user provided. So user will enter that number. Then you have to create that list. That is the first thing. Okay, now I'll come how you can proceed on that, but let me just tell you how to do it. So user will provide number of items. So that will help you to create the list. Now, once the list is created, you have to define a function to calculate all prime numbers, and next would be store all prime numbers in a new list. Okay. Now tell me where exactly is the confusion? Prime numbers are divisible by itself and 1. That is what prime number is all about. Right. So just give it a thought on this assignment. It would need all the existing things that we have learned so far. And also there is one more thing which I will just cover right now that will help you to create a list. but rest of the things will be pretty, straightforward. User will provide you the number that will help you to create the list. Once the list is created, you have to define a function, write a function. This function like define prime. So that function will calculate, like it will be like define prime or something, and you will pass the number. And in that, if num is prime, then return num. That's it. So this is how it will be. Now, if the number is prime, so this statement here, this is where exactly you need to do the calculation. You following me? So this is where so this condition is where you have to write, where you will calculate that the number is a prime number or not. If it is a prime number, then you will return. If it is not a prime number, then just ignore, because I have not written anything after that.
Okay.
Like I have not mentioned anything, any else or something like that. So if only the number is a prime number, then only it will return that. So what we have to do, we have to catch that return, and we have to create a blank list, which we have created as part of the other one, where we have just appended them and created a new list of all the prime numbers.
Okay.
Understood?
Yeah.
So that is what, just give it a try tomorrow. It will be a good practice. Just think it through. And tomorrow we can see, how much we have progressed.
Sure.
But right now, what we can do is we can just, try just, okay, there is one more thing I'll just show you, which will be needed as part of this assignment, which is list comprehension. Now, what is list comprehension? So list comprehension is something, okay, and until now we were creating lists manually, right? We were writing L1 is equal to square bracket and we are putting some numbers here like that, right?
Yeah.
So this is how we were creating lists until now, but this is extremely manual. Let's say my need is to create like this, exactly like this, or let's say I've been asked to create a list of 10 numbers. All 10 numbers I have to create a list. So, or 100 or 1000. Until 10, 100 you can write on your own, 1, 2, 3, 4 like that. But let's say you have been asked to create a list of 1 million records, 1 million numbers. So would you be able to write it on your own? Of course not. It will take ages and decades to run.
Yeah.
So the technique that we have is comprehension, list comprehension. What comprehension will do? Comprehension will help me to create lists in just one single line. It will just help me to write a particular list, or this could go for dictionary also. We'll see that later. But now let's just keep it simple and try it in as part of list. So this will, one second, let me just write it down first. Let's say here L2 is equal to, now within square bracket means we know it's a list. So if I run this, if I see what is in L2, this is an empty list. But instead, what we are trying to do is, we are trying to create it on our own. What is the syntax? The syntax is I for I in range of 50. And if I run this now, this will be my list of 50 elements. So just understand what is happening. So this is one line statement for creating a list. So I'm using a loop. Now see loop, how beneficial it is. At every point, we will be using loops, conditional statements. So what are we doing? So for I in range 50, we know that, right? I is something which starts from 0 and it will go until 50 position. 50 minus 1, 49 position. If it is starting from 0. So that is a loop which will run 50 times. Every time what I am trying to do is I'm just storing that value in the list. As simple as that. So I'm just storing that value. I'm not doing anything else. So 0, 1, 2, 3, every time that value is getting stored. Now, can we just, let's keep it small. Yeah. Can we just play around with it? Let's see if I do multiply, what will happen? Yes, this is working. If I do something else, I divided by I plus 3. Yes. So this list comprehension will essentially give me the power to create a list on any type, on any of my needs or powers. So that is how list comprehension will help. So the first thing is understand how it works. List comprehension, list name is equal to square bracket, then your item, and then followed by loop for loop. So this is the first thing. And then you have to do a for loop for n times. N is as many times you want to do it. So that is how essentially a list comprehension statement looks like. List comprehension is equal to item, and then after that, you just write a for loop for n number of times. As simple as that. So this will help you to create a list.